What if most of the universe was invisible? Not far away, not hidden behind dust, not waiting to be discovered by a better telescope, but already here, shaping galaxies, holding the cosmos together while remaining completely unseen. Because tonight, we are stepping gently into one of the strangest ideas in all of science, that most of reality may be made of something that does not shine, does not glow, does not reflect light at all, and yet still shapes the universe everywhere. This is dark matter, not a shadow, not ordinary dust, not dark clouds drifting unseen between the stars, but something deeper, a form of matter that seems to reveal itself only through gravity. So let the room grow quiet. Let the day move a little farther away, and stay with this for a moment. If most of the matter in the cosmos is invisible, what does that mean for the universe you thought you knew? And what does it mean for the sky above you, if the stars are only the bright surface of something much larger? Now let's begin. At first, the idea sounds almost impossible. Matter should be visible, or at least detectable through ordinary light. We are used to a simple pattern. If something is there, it can shine, or block light, or reflect it, or heat up and reveal itself in some way. Dark matter refuses that instinct. It does not appear to interact with light in the ordinary ways matter usually does. And yet, again and again, the universe behaves as though dark matter is there. This is what makes the subject so beautiful. Dark matter was not invented because scientists wanted mystery. It was forced upon them by the behavior of the cosmos itself. Imagine this. You are looking at a galaxy from far away, a spiral of stars turning through the dark, beautiful, measured, orderly, the kind of thing that feels like it should be understandable. If only the visible matter were present. The stars near the outer edge of the galaxy should move more slowly than they do. That is what ordinary gravity would predict. The farther from the bright central mass you go, the weaker the pull should become. The outer stars should drift more gently, but they do not. They move too fast, far too fast, as if the galaxy contains much more mass than the eye can see. This was one of the first great clues. Galaxies were rotating as though they were wrapped in invisible matter, a hidden gravitational halo, a dark structure outweighing the stars themselves. Imagine this, a great spiral galaxy turning in silence. The visible stars are only the bright sparks inside it. Around and through that visible structure lies something much larger, something the eye cannot catch, something that does not glow, and yet something heavy enough to hold the whole system together. That is the first emotional shock of dark matter. The visible universe may not be the main body at all. It may be the luminous trace of something bigger and unseen. For many people, that idea feels almost philosophical before it feels scientific, because it means that appearance is not the same as structure. What shines is not necessarily what rules. And dark matter is one of the clearest examples of that in all of cosmology. The story did not begin with modern headlines. It goes back more than 90 years. Astronomers studying clusters of galaxies noticed something troubling. The galaxies inside those clusters were moving too quickly to be held together by the visible matter alone. There had to be more mass present, much more. That early clue was unsettling enough. But later, when astronomers studied the rotation curves of individual galaxies in more detail, the evidence grew much stronger. Again and again, galaxies behaved as though most of their mass was invisible. This matters, because dark matter was not proposed because one strange object behaved oddly. It emerged because many different cosmic systems kept pointing toward the same hidden conclusion. Imagine this. You keep measuring the universe, galaxies, clusters, large structures, and every time you ask gravity to account for what you see, Gravity seems to answer back with the same quiet correction. There is more here than light reveals. That is one of the reasons dark matter remains so compelling. Different observations, different scales, different methods, and yet the same deeper suggestion. The universe contains hidden mass. Now, it is important to be careful. Dark matter is not just ordinary matter hiding badly. It is not a cloud of cold rocks, not dim stars we failed to count, not planets drifting unseen in huge enough numbers to solve the problem. Astronomers have tested those simpler ideas. They do not explain what we observe. Whatever dark matter is, it appears to be something fundamentally different from ordinary matter, something that exerts gravity, but does not behave like the familiar matter that makes stars, planets, oceans, bodies, and dust. Imagine this. Everything you have ever touched, everything warm, bright, heavy, visible, ordinary, all of it belongs to only one category of matter: baryonic matter, ordinary matter, the kind that builds atoms and chemistry and daily life. Dark matter, if our current understanding is right, belongs to another category entirely, a hidden companion to the visible universe, not emotionally hidden, physically hidden from light. That is why the phrase dark matter can be a little misleading. It sounds as though it is merely dim, but it is more radical than that. It may be transparent to light, unlit in principle, invisible not by accident, but by nature. Imagine this, a galaxy without dark matter. Its outer stars would not hold their speed. Its visible form would not behave the way we observe real galaxies behaving. Now imagine the same galaxy surrounded by an enormous halo of hidden mass. Suddenly the motions make sense. The rotation curve flattens. The outer stars keep moving quickly. The whole system becomes more stable in the way observations demand. That invisible halo is one of the most useful ways to picture dark matter. Not because we have photographed the halo itself, but because the motions of visible matter seem to require it. And galaxies are only part of the story. Dark matter also appears to matter at larger scales. Galaxy clusters, the cosmic web, the way structure formed in the early universe. This is where dark matter stops being only a local puzzle and becomes part of the architecture of everything. Imagine this. The early universe is young. Matter is beginning to gather. Tiny fluctuations in density begin to grow under gravity. Over immense spans of time, those fluctuations become galaxies, clusters, and the web-like large-scale structure of the cosmos. But without dark matter, those structures do not form in the same way, not quickly enough, not with the same patterns we observe. Dark matter seems to provide gravitational scaffolding, a hidden framework around which visible matter later gathers. That is one of the most astonishing possibilities in modern science. The stars may not be the framework of the cosmos. They may be the decoration on top of a deeper, invisible structure. Imagine this, the Milky Way drifting through space, beautiful in light, immense in scale, and all around it, through it, holding it, an unseen halo of dark matter extending far beyond the visible stars. A hidden mass more dominant than the luminous galaxy itself. This is why dark matter can feel so humbling. It suggests that what you see in the night sky is not the full body of the universe, only the part capable of shining. And perhaps that is what makes dark matter so haunting. The possibility that light is not the main story, that visibility is not centrality, that most of what matters gravitationally may remain forever unseen by ordinary eyes. Still, science asks more than emotional reaction. It asks for evidence. So how do we know dark matter is there if we cannot see it? The answer, again and again, is gravity. Gravity reveals mass. Mass bends light. Mass governs motion. Mass shapes the paths of stars and galaxies, and the large structures of the universe. And when those paths cannot be explained by visible matter alone, dark matter enters not as fantasy, but as the best current explanation. Imagine this. A beam of light passes through a region of space containing a massive cluster of galaxies. The cluster bends the light behind it. That bending can be measured, and sometimes the amount of bending tells us something extraordinary. There is more mass there than the visible galaxies and gas can account for. Again, the same quiet message: hidden mass. This phenomenon is gravitational lensing, and dark matter appears in it not as a glowing thing, but as missing visible mass that gravity still insists on counting. That is one of the recurring themes of tonight's journey. Dark matter is not directly seen, it is inferred. Its presence is written into consequences, into motion, into bending, into structure, into what the universe does. And that may be one of the deepest lessons dark matter offers. Reality is not obligated to be fully visible. Imagine this: a universe in which most matter is invisible, a sky in which stars are real but incomplete, a cosmos built partly from something that does not shine, but still holds galaxies in its grip, a world where gravity knows more than sight. That is the world modern cosmology seems to describe. In the next part, we go deeper into the evidence. We'll move from the basic mystery into the strongest clues dark matter has left behind: galaxy rotation, gravitational lensing, the bullet cluster, and why so many different observations seem to keep pointing toward the same hidden mass. For now, rest with this. Dark matter is not just an abstract idea. It is our best current name for the invisible mass that seems to shape galaxies, clusters, and the large-scale structure of the universe. It does not shine. It does not announce itself in light. And yet the cosmos keeps behaving as though it is there. Now we move deeper into the evidence, because a mystery this large cannot rest on mood alone. It has to leave marks. Repeated marks. Precise marks. The kind the universe keeps making even when no one asked it to be mysterious. And dark matter does. Again and again, in galaxies, in clusters, in bent light, in the large-scale structure of the cosmos. The first great clue comes from motion, not dramatic motion, not explosions, not violent collapse, just rotation, the quiet turning of galaxies through the dark. Imagine this: a spiral galaxy seen from above, a bright central bulge, long, graceful arms, billions of stars turning together. At first it looks almost peaceful, the kind of object whose motion should be easy to predict. If most of the mass were concentrated in the visible center, then stars farther out should orbit more slowly. That is what happens in simpler systems. Closer things move faster, farther things move more gently. The pull weakens with distance. The outer parts should lag. But real galaxies do not behave that way. Their outer stars keep moving fast, much too fast, as if the visible galaxy were embedded inside something much larger and heavier. This is called a rotation curve, a graph of orbital speed against distance from the center. And if galaxies contained only the stars and gas we can see, those curves should slope downward. They should fall. But many of them do not. They stay flat, almost stubbornly flat, as if gravity is being supplied by an invisible halo extending far beyond the bright stars. That is one of the cleanest clues in all of astronomy. The galaxy moves as though it contains much more matter than it shows. Imagine this. You keep measuring one spiral galaxy after another. Different shapes, different sizes, different locations in the universe. And still the same pattern appears. The visible matter is not enough. Not enough to explain the speed. Not enough to explain the stability. Not enough to explain the turning. This is why dark matter became so persuasive. Not because one galaxy behaved strangely, but because so many did. The cosmos kept repeating itself, and repetition is one of science's deepest forms of persuasion. Now imagine something larger, not one galaxy, a cluster, hundreds or even thousands of galaxies bound together by gravity, a great city of galaxies moving within one larger gravitational system. You measure their speeds, you measure the hot gas between them, you count the visible mass as carefully as you can, and once again, the same conclusion rises. There is too much motion, too much binding, too much gravity for visible matter alone. Clusters seem heavier than light can explain. This was one of the earliest signs, even before galaxy rotation curves became famous. Something hidden appeared to be holding these systems together, a mass that could not be accounted for by what's shown. Imagine this: a vast cluster of galaxies drifting in a shared gravitational field. Each galaxy visible, each one countable, and yet the total visible matter still falls short of what gravity demands. The cluster behaves like a system with a deeper skeleton, a hidden weight, a dark architecture. That phrase matters, dark architecture. Because dark matter is not merely extra stuff sprinkled into the universe, it seems to provide structure. It shapes how things gather, how they remain bound, how visible matter settles into the patterns we observe. Then comes another clue, not from motion, from light. Because mass does not only govern the paths of stars and galaxies, mass also bends light. That is one of the great lessons of relativity. Enough mass curves space-time, and curved space-time redirects the path of passing light. This is gravitational lensing. And dark matter appears here with remarkable honesty, not by glowing, but by bending more light than the visible mass should be able to bend. Imagine this. You look at a distant galaxy far behind a massive cluster. Its light passes through the cluster's gravitational field on the way to you. The image stretches, smears, warps, perhaps even splits into arcs and rings. By measuring that distortion, astronomers can estimate how much mass lies in the intervening cluster. And again, the answer comes back larger than visibility allows. More mass is there than the stars and hot gas alone can explain. That is one of the most elegant pieces of the puzzle. Gravity measures what sight cannot. The universe keeps leaving the same note. There is more here than light reveals. Imagine this: a map of visible galaxies, and over it, a map of total gravitational mass inferred from lensing. The two maps overlap, but not perfectly. The hidden structure extends farther, heavier, broader, as though the luminous universe is nested inside a larger invisible one. This is where dark matter begins to feel less like a speculative ingredient, and more like a repeated gravitational fact. Now we come to one of the most famous pieces of evidence of all: the bullet cluster. The bullet cluster is not one cluster, but two galaxy clusters that have collided. That alone is dramatic enough. Vast structures crossing through one another, galaxies passing, gas colliding, gravity redistributing the whole system. But what makes the bullet cluster so important is that different parts of the collision separate. The hot gas, which contains much of the ordinary matter, interacts strongly and slows down. It crashes, it heats, it glows in X-rays. But the galaxies themselves pass through more easily. And when astronomers mapped the gravitational mass through lensing, the strongest mass signal was not centered on the slowed gas. It was centered closer to the galaxies. That mattered enormously, because it suggested that much of the mass had passed through the collision without interacting like ordinary gas. It behaved as though it were mostly collisionless. That is exactly the kind of behavior dark matter was expected to have. Imagine this: two clusters collide. The visible hot gas piles up and glows where it crashes. But the main gravitational mass appears offset from that gas. It has moved on. Still there, still heavy, still bending light, but not behaving like ordinary matter. That is one of the most persuasive images in modern cosmology, not because it proves every detail, but because it shows visible matter and gravitational mass pulling apart in a real observed system. The light says one thing, gravity says more. This is why the bullet cluster became so central to the dark matter story. It made the hidden mass feel less like bookkeeping and more like substance. Not visible substance, but something real enough to separate from ordinary matter under extreme conditions. Imagine this, the universe setting up its own experiment. Two giant clusters, a collision, hot gas glowing in one location, mass revealed somewhere else through lensing, a cosmic demonstration written across millions of light years. Science rarely gets examples that dramatic, and dark matter has been shaped by exactly those moments. Not a single proof, but converging lines of evidence that keep leaning in the same direction. Now step even farther back, beyond galaxies, beyond clusters, out toward the largest structure of the universe, the cosmic web. The universe at its biggest scales is not random. Matter forms filaments, knots, voids, a vast network of structure stretching across unimaginable distances. And simulations of cosmic structure formation work far better when dark matter is included. Without dark matter, the web does not emerge in the same way. Not with the same speed, not with the same distribution, not with the same cosmic texture we actually observe. This is another reason dark matter remains so compelling. It does not only solve local puzzles, it helps explain the universe's large-scale anatomy. Imagine this. The early universe begins nearly smooth. Tiny density fluctuations ripple through it. Over billions of years, gravity amplifies those differences. Matter gathers, filaments grow, galaxies form, clusters emerge, voids open. A hidden scaffold becomes visible only after ordinary matter falls into it and lights up. That is one of the most breathtaking ideas in modern cosmology. The visible universe may have formed by settling into an invisible framework that came first. Dark matter, in that picture, is not decoration, it is infrastructure. And that word changes the emotional feel of the whole subject. Because infrastructure is not glamour, it is support, foundation, load-bearing presence. Dark matter may not be the visible beauty of the universe. It may be the hidden thing that lets beauty keep its shape. Imagine this. Stars glowing like lanterns, galaxies turning like luminous cities, clusters hanging in the dark, and beneath all of it, a silent, unseen mass giving structure to what can shine. That is why dark matter can feel both unsettling and strangely graceful. It asks us to accept that the visible universe is not the whole story, but it also offers a larger, deeper kind of order. Of course, honesty matters here too. Dark matter is still inferred. We have not captured it directly in the way we capture ordinary particles in ordinary experience. We do not yet know exactly what particle or substance it is, if that is even the right level of description. That uncertainty is real. But uncertainty about its identity is not the same as uncertainty about the gravitational problem itself. The evidence that something unseen is shaping cosmic structure remains powerful. Imagine this. You know someone is in the room not because you see them, but because you hear the floor respond. You watch objects move. You feel the air change. The body remains unseen, but the effects are too consistent to ignore. Dark matter is something like that on a cosmic scale. We do not yet see the actor directly, but the stage keeps moving as though it is there. That is why dark matter remains one of the great open stories in science. The evidence for the hidden mass is strong. The exact identity of that hidden mass remains unfinished. And it is in that space between strong evidence and incomplete understanding that the subject becomes so alive. In the next part, we move from evidence to possibility. If dark matter is real, what might it actually be? A particle, a family of particles, a deeper modification of our picture of matter, or a sign that gravity itself still holds another secret. For now, rest with this. Galaxies rotate too fast. Clusters weigh too much. Light bends more than visible matter allows. And the large-scale structure of the cosmos seems to grow from hidden scaffolding. Again and again, the universe behaves as though something unseen is there. Now we move from evidence to possibility. Because once the universe keeps behaving as though hidden mass is there, another question begins to rise. What is it? Not what does it do, not what does it explain, but what is dark matter itself? And this is where the subject becomes both exciting and unfinished. Because dark matter is one of the clearest examples in science of a powerful idea whose effects seem real, while its true identity still remains unknown. Imagine this. You know something is there. You have watched galaxies rotate as though it is there. You have watched clusters weigh more than visible matter allows. You have watched light bend around invisible mass. You have watched structure in the universe behave as though hidden scaffolding exists. And still, when you ask the simplest possible question, what is it made of? Science becomes quieter, more careful, more provisional. That does not mean the subject becomes weak. It means it becomes alive. Because this is where observation ends and the search for nature begins. For many years, one of the leading possibilities was that dark matter might be made of new particles. Not ordinary particles like protons, neutrons, or electrons. Not the familiar building blocks of atoms. But something beyond the standard model of particle physics. Something massive enough to exert gravity, and dark enough not to interact with light in ordinary ways. This is why dark matter became not only an astronomical question, but a particle physics question too. The cosmos seemed to be asking for a new ingredient. One of the most famous candidates was the WIMP, the weakly interacting massive particle. The name sounds technical, but the idea is simple enough in spirit. A particle with mass, enough mass to contribute real gravity, yet so weakly interacting with ordinary matter and light that it would pass through much of the visible universe almost without notice. That possibility was elegant, perhaps too elegant, because it seemed to fit what many physicists already hoped might exist beyond known physics. And for a long time, WIMPs became one of the central dark matter candidates. Imagine this. A universe filled not only with atoms and radiation and visible matter, but with a ghost population of heavy particles drifting through everything, through stars, through planets, through your own body. Not because they are magical, but because they barely interact. That image gave dark matter a strange intimacy. It would not merely be out there between galaxies. It would be passing through the Earth right now, through the room, through the air, through you. And yet you would never feel it, because gravity would be the only language it speaks clearly enough for us to hear. For decades, scientists designed experiments to detect such particles directly, deep underground, shielded from noise, protected from cosmic rays, waiting for the tiniest possible interaction between dark matter and ordinary matter. A rare collision, a faint signal, a whisper of hidden mass touching the visible world. That search is one of the most patient in modern science, because the event, if it happens at all, might be incredibly rare. A tiny flicker in a detector after long silence, a nearly invisible footprint from something thought to surround galaxies. And yet, so far, no universally accepted direct detection has arrived. There have been hints, tensions, moments of hope, but no clear final capture. That matters, because the dark matter story is shaped as much by what has not yet appeared as by what has. Imagine this. An experiment waits for years in the dark, sensitive enough to notice impossibly small events, and still the hidden matter does not clearly reveal itself. The room remains quiet, the detector remains patient, the cosmos remains withholding. That does not kill the idea, but it changes its emotional texture. Dark matter begins to feel less like a clean, expected discovery, and more like a deeper missing piece. Another major candidate is the axion. Much lighter than the heavy WIMP picture, still hypothetical, still elusive, but attractive for different theoretical reasons. Axions would not behave like ordinary matter either. They would be extraordinarily hard to detect, and yet they could, in principle, fill the universe in vast numbers, quietly contributing the hidden mass cosmology seems to require. This is one of the strange things about the search. Dark matter might be heavy and rare, or light and abundant, or more subtle than either picture first imagined. The space of possibility is wide, because the evidence tells us strongly what dark matter seems to do, but not yet exactly what it is. Imagine this. You are trying to identify a hidden animal in a forest. You hear the branches move. You see the pattern left in the ground. You watch the trees sway as though something large passed through. You know something is there, but you still do not know its shape. Dark matter is something like that at the scale of the universe. The tracks are strong. The animal remains unseen. There are other possibilities too. Sterile neutrinos, primordial black holes, whole hidden sectors of particles interacting mostly with themselves and gravity. Ideas both conservative and radical have been proposed. Some elegant, some desperate, some beautiful, some complicated. That variety is not a sign of failure. It is a sign that the question remains open enough to invite real imagination under discipline. And yet, there is another path, a more unsettling one. What if dark matter is not matter at all? What if the real issue is not hidden substance, but gravity itself? Some physicists have explored that possibility. Perhaps on very large scales or very low accelerations, gravity does not behave exactly the way our simplest assumptions predict. Perhaps the missing mass is not missing mass, but missing understanding of gravitational law. This family of ideas has taken several forms, most famously, modified Newtonian dynamics and later relativistic extensions. The details vary, but the emotional core is the same. Maybe the universe is not full of unseen particles. Maybe we are reading gravity too simply. Imagine this. Galaxies rotate too fast. Clusters weigh too much. Light bends more than visible matter allows. You can answer that by adding hidden matter, or you can ask whether the law itself still holds in the form you expected. This is one of the deepest scientific forks in the road. Invisible matter or incomplete gravity. There is something elegant about the second idea, because it tries to explain the evidence without introducing a new cosmic substance. Instead, it asks whether the force we think we understand has another layer. But modified gravity faces its own struggles. Some observations fit poorly. Some large-scale structures remain difficult. And the bullet cluster in particular has often been treated as a major challenge for simple modified gravity alone. Because the gravitational mass seems displaced from the ordinary visible gas in a way that hidden matter explains more naturally. This is where the conversation becomes subtle. Dark matter and modified gravity are not just rival slogans. They are attempts to respect the same evidence without forcing the universe to become simpler than it is. Imagine this. Two scientists looking at the same sky. One says there must be hidden matter. The other says gravity must run deeper than we think. Both are trying to save coherence. Both are listening to the same cosmos. The disagreement is not about whether the evidence matters. It is about what kind of reality best explains it. That is science at its most honest. Not noise, not certainty pretending to be stronger than it is, but disciplined disagreement in the presence of real mystery. And that is why dark matter remains so powerful, because the evidence is strong enough to demand an answer, but the answer is still not fully in hand. This puts dark matter in a rare category. It is not a weak idea drifting on speculation alone, nor is it a closed case. It is something in between, a hidden reality whose fingerprints seem clear and whose face remains withheld. Imagine this: galaxies turning as though wrapped in invisible halos, clusters bending light with unseen weight, the cosmic web growing around hidden scaffolding, experiments waiting underground in silence, theories reaching outward, particles, axions, new sectors, modified gravity, and still no final revelation. That is not emptiness. It is the pressure of an unfinished truth. There is something almost beautiful in that pressure, because it means the universe is still capable of surprising us at its foundations, not only in distant exotic corners, but in the basic question of what most matter actually is. Think of the scale of that. We are not talking about a rare object, not a strange star, not a peculiar galaxy, but perhaps the majority of matter in the universe, and we still do not know its true identity. That should make the night sky feel different, more incomplete, but also more alive. Imagine this: the stars above you are real, the galaxies are real, the visible universe is real, and yet it may be only the luminous skin of a much larger hidden body, a body whose mass shapes motion, light, and structure, while refusing, so far, to tell us exactly what it is. That is why dark matter feels both scientific and philosophical. It touches evidence, but it also touches humility. It reminds us that reality does not owe us visibility. It does not owe us intuitive ingredients. It can support galaxies with something we cannot yet name with confidence. In the next part, we step back one final time. We'll gather what dark matter has taught us, why this invisible mass matters so much, why it continues to hold science in tension between evidence and uncertainty, and what it means that the universe may be built around something we still cannot see directly. For now, rest with this. Dark matter may be a new particle, a family of particles, a hidden sector, a sign that gravity still has another layer, or something even stranger. But whatever its final identity turns out to be, the universe keeps behaving as though hidden mass is there. Now we step back one final time, because dark matter is not only a scientific puzzle, it is one of the clearest reminders that the universe is under no obligation to be fully visible. That may be the deepest feeling it leaves behind. Not just confusion, not just curiosity, but a kind of humility, because for centuries, light felt like the great revealer. We learned the stars through light, galaxies through light, the history of the cosmos through light. The sky seemed to offer its truth by shining. And then dark matter changed the tone of that story. It suggested that light may reveal only part of what is there, that the visible universe may be real, beautiful, measurable, and still incomplete. Imagine this: a galaxy glowing in the dark, spiral arms lit with stars, nebulae drifting, clusters shining, a structure so beautiful it feels self-sufficient. And yet around it, through it, holding it, may be a far greater mass that never shines at all. That is why dark matter feels so strange. It does not remove beauty, it deepens it. But it also unsettles it, because it tells us that what glows is not necessarily what governs. The stars are real, but they may not be the main body of the galaxy, only the visible trace of something larger. That idea changes the emotional scale of the universe. It makes reality feel layered, surface and structure, light and gravity, appearance, and architecture. And perhaps that is why dark matter continues to stay in the mind. Because it is not just an answer to a technical problem. It is a correction to human instinct. We are drawn to what announces itself, what shines, what can be pointed to directly. Dark matter does none of those things, and yet its effects seem too consistent to ignore. Imagine this. You look at the night sky and see stars. You study galaxies and see light. You map clusters and detect hot gas. But gravity keeps counting more than sight can count. Again and again, the universe behaves as though there is hidden weight behind the visible scene. That repeated mismatch is the real emotional center of dark matter. The feeling that reality may contain more than observation alone first promises. This is one of the reasons the subject matters so much. Dark matter is not a decorative mystery added to cosmology for drama. It sits close to the load-bearing structure of the universe. If it is real, it helps explain why galaxies hold together the way they do, why clusters weigh what they weigh, why large-scale cosmic structure formed as it did, why the visible universe has the patterns we observe at all. That is not a small role, that is foundational. Imagine this. Remove dark matter entirely, not just as a name, as a physical contribution. Let the universe keep only ordinary visible matter. Suddenly, galaxies rotate differently. Clusters become harder to explain. The cosmic web changes. Structure formation slows or shifts. The universe we actually observe becomes harder to recover. That is why dark matter is not just about missing mass. It is about cosmic form. It may be part of the reason the visible universe has been able to become what it is. A silent infrastructure beneath the luminous world. That phrase matters. Silent infrastructure. Because infrastructure is easy to overlook. It does not call attention to itself. It supports. It carries. It holds weight without demanding admiration. Dark matter, if it is truly there, may be one of the universe's deepest examples of that kind of hidden support. Imagine this. Stars like lanterns. Galaxies like cities of light. Clusters like glowing archipelagos in the dark. And beneath all of it, an unseen gravitational framework letting those bright forms gather and remain. There is something almost moving in that the cosmos might be built not only from what shines, but from what supports shining. Of course, honesty still matters. We have not completed this story. We do not yet know the final identity of dark matter, not with full confidence, not in the way science prefers when a mystery has truly closed. That uncertainty is real, and it should remain real in the way we speak, because science stays strong not by pretending its questions are finished, but by describing honestly where its confidence ends and where its search continues. Dark matter belongs exactly in that space. Strong evidence, incomplete identity, a universe behaving consistently in one direction, and a final explanation not yet fully secured. Imagine this. You stand at the edge of a great hidden landscape. The tracks are clear. The pressure on the ground is real. The shape of the forest tells you something enormous has moved through it, but the creature itself remains unseen. That is where we are with dark matter, not empty-handed, not fully satisfied, and that is a very scientific place to be. Because the goal is not comfort, the goal is truth, and truth sometimes arrives in layers. First the effects, then the pattern, then the confidence, and only later, perhaps, the final nature of the thing itself. Dark matter may yet be named clearly: a particle, a hidden family of particles, a new sector of reality, a deeper correction to gravity, or something even more surprising than our current imagination has prepared for. But even before that final answer comes, dark matter has already changed us. It has changed cosmology, changed the questions we ask about matter, changed the emotional tone of the visible universe, changed what it means to look at the night sky and call it complete. Imagine this. You look up again now. The stars are still beautiful. The galaxies are still beautiful. Nothing visible has become less real. But around every bright thing there is now a deeper possibility, that the visible world may be suspended inside a larger invisible one, that gravity may know more than sight, that the cosmos may be built from hidden mass the way a great structure is built from beams no one admires directly. That is what dark matter offers in the end. Not only mystery, perspective. It teaches that reality may be fundamentally richer than appearance, that what matters most structurally may not be what announces itself most easily, that science sometimes advances not by seeing more brightly, but by learning how to trust consequences. And that is a beautiful kind of maturity, not the loss of wonder, a deeper form of wonder, one disciplined enough to live beside invisibility. Imagine this, a universe where most matter is unseen, a sky where stars are not the whole story, a cosmos whose great visible tapestries are held in place by something dark, quiet, and still unnamed. Not fantasy, not superstition, but the best unfinished reading of evidence we currently have. That is why dark matter remains so haunting, not because it is spooky in a shallow sense, but because it reveals how much of reality can remain hidden even in a universe so full of light. So if you carry anything with you from tonight's journey, let it be this. Dark matter is not just a missing piece in astronomy. It is a reminder that the visible universe may be only the bright surface of a deeper structure. A structure held by gravity, inferred through motion, suggested by lensing, echoed in clusters, woven into the cosmic web, and still, for now, hidden from direct sight. Now the journey begins to quiet. The galaxies soften. The invisible halos drift back into thought. The question remains open, but no longer empty, only unfinished. For now, let the stars remain what they are, beautiful, real, luminous, but not complete. And let that incompleteness settle gently into the dark. The universe may be held together, in large part, by something we still cannot see. Rest there for a moment, and when sleep comes, let it come softly. Now we arrive at the final view. Not only what dark matter seems to do, not only the evidence it leaves behind, not only the possible forms it might take, but why it matters so much that the universe may be built around something we still cannot see directly. Because dark matter is not just another scientific topic. It changes the emotional shape of reality. For a long time, the visible universe felt like the main story. Stars, galaxies, nebulae, clusters, the bright architecture of the cosmos. It seemed natural to assume that what shines is what matters most. Dark matter unsettles that assumption. It suggests that the luminous universe may be real, beautiful, and measurable, and still only partial. That may be the deepest feeling it leaves behind. Not that the universe is empty, not that it is deceptive, but that it is layered, surface and structure, light and weight, appearance and foundation. Imagine this. A spiral galaxy turning in silence, its stars bright enough to photograph, its dust lanes visible, its shape elegant and complete to the eye. And yet around it, through it, holding it together, there may be an invisible halo far more massive than the stars themselves. The beauty remains, but now it feels suspended inside something deeper. That is why dark matter lingers in the mind. It does not erase wonder, it enlarges it. But it also asks for humility, because it means sight is not enough. Science has always depended on light, on what arrives at the telescope, on what reflects, glows, radiates, or blocks. Dark matter reminds us that reality can leave decisive evidence without becoming visually generous. It can bend light, guide motion, hold galaxies together, shape the growth of structure, and still remain hidden. There is something very mature about that lesson. The universe does not promise to reveal itself only through what is easy to see. Sometimes it reveals itself through consequences, through patterns, through tensions in the data that refuse to disappear. Imagine this. Again and again, the same quiet mismatch appears. Galaxies rotate too quickly. Clusters weigh too much. Light bends more than visible matter allows. The cosmic web forms more naturally with hidden scaffolding than without it. No single observation has to carry the whole subject alone, but together they lean in one direction, toward hidden mass, toward unseen structure, toward a cosmos whose visible beauty may be only the bright surface of a darker framework beneath. That is what makes dark matter so powerful scientifically. It is not one oddity. It is a repeated gravitational signature, a pattern written across many scales, a coherence too persistent to dismiss casually. And yet the identity remains unfinished. That unfinished quality matters too, because dark matter is not a closed story wearing the costume of a mystery. It is a real mystery, strongly evidenced, still incomplete. That puts it in a rare category, not fantasy, not certainty, something in between, a hidden reality whose fingerprints seem clear and whose face remains withheld. Imagine this. The universe has already told us that something is missing from the visible account, but it has not yet told us the full name of what is missing. It has given us structure without direct revelation, evidence without full possession, nearness without capture. There is beauty in that, not because ignorance is beautiful by itself, but because the search is honest. Dark matter shows science doing what it does best, listening carefully, following consequences, refusing both panic and false closure. That is one reason the subject feels so alive. It is not finished enough to become stale, and not weak enough to drift into pure speculation. It remains under tension, evidence pulling from one side, identity remaining hidden on the other. Imagine this. Deep underground, detectors wait in the dark. Above them, the Earth turns. Beyond the Earth, the galaxy turns. And perhaps through all of it, dark matter passes in immense, silent abundance, still refusing to reveal itself in ordinary light. That image contains something almost poetic, a hidden ocean of mass moving through the visible world and leaving only gravity to speak on its behalf. But even if the final particle is never the answer, even if gravity itself needs deeper revision, the lesson will remain. The visible universe is not the whole universe. That is already one of the most important shifts dark matter has given us. It has changed the tone of cosmology, changed how we think about matter, changed what it means to look at the sky and ask what is really there. For centuries, the stars felt like the main body of the night. Now they may also feel like tracers, lanterns hanging inside a larger invisible architecture. Not less real, not less beautiful, but less complete than they first appeared. Imagine this. You look up at the Milky Way, a soft river of light crossing the dark, and hidden around that luminous band, stretching far beyond what the eye can follow, lies an unseen halo of mass. No glow, no signal to ordinary sight, and yet enough gravity to shape the galaxy's behavior. That image may be one of the quietest revolutions in modern thought. The night sky can remain exactly as beautiful as before, and become far more incomplete at the same time. Dark matter teaches that incompleteness without despair, and that is a rare kind of knowledge. It says the universe may be stranger than our senses suggest, but still lawful, still measurable, still open to patient understanding. There is comfort in that, because mystery is easier to live beside when it remains structured. Dark matter is not chaos. It is disciplined uncertainty, a hidden ingredient implied by repeated evidence, a question held inside the grammar of real physics. Imagine this, A cosmos where what shines is only one layer, where gravity knows more than sight, where galaxies are held by halos we cannot photograph directly, where the largest structures in the universe may have formed inside invisible scaffolding, and where human thought, instead of retreating from that darkness, keeps going, measuring, testing, waiting, refining. That too is part of the meaning of dark matter. Not only what the universe hides, but what curiosity does in response. It stays, it listens, it keeps asking. So if you carry anything with you from tonight's journey, let it be this. Dark matter is not merely a missing substance in astronomy. It is a reminder that the visible universe may be only the bright surface of a much deeper reality. A reality traced by gravity, suggested by motion, mapped by lensing, echoed in clusters, woven into the cosmic web, and still, for now, hidden from direct sight. Now the journey begins to quiet. The galaxies soften. The invisible halos drift back into thought. The question remains open, but no longer empty, only unfinished. For now, let the stars remain what they are: beautiful, real, luminous, but not complete. And let that incompleteness settle gently into the dark. The universe may be held together, in large part, by something we still cannot see. Rest there for a moment, and when sleep comes, let it come softly.